Welcome back, and this is part 3 of the series that I am doing in conjunction with PAMIS and Motivate, and we're talking about sensory processing. The first 2 parts were about parental sensory regulation, and I really encourage you, if you've not watched these, to go and watch these first before you watch this part. It'll make much more sense. There's lots of descriptions about what sensory processing is, and I'm sure over the years you have heard lots of different variations as well. But I'm just going to describe it simply as referring to the way that the nervous system receives messages from the senses and turns them into responses. So the information that comes in is interpreted and sends information back. It's apparent to me that most of us have learned when we were younger, or even learn now, that the brain is the mastermind of the operation and the body just does what it's told. And this is not accurate. It's much more of a continual loop between both the body and the brain. The other myth is that we have 5 senses, and if you've heard me speaking before, you might know the answer to this already, but just have a little quick think how many we might have. So a clue was that it's not 5. So 6 or 7. In actual fact, we've got 8. I'll name them just now, but you don't have to remember the names of these, and we are going to be going over these in more detail at another point. So we've got sight, we have touch, we have smell, we have taste, we have hearing, we have proprioception, which is messages from our muscles and joints about where we are in space, vestibular, which is our balance system located in the inner ear and also is related to posture, and our interoception, which is our internal sense, a newly written about but not newly known about sense. We've always known we've got this internal kind of gut sense. So let's think about sensory processing and where the loop actually starts. Well, it starts with our bombardment of sensory information, sensory stimuli. We are bombarded, and I mean bombarded, every day. There's so much stimuli to contend with. Now, you may have had a little bit less since you've been in lockdown, or it may have felt like you've not been able to get away from the stimuli because you're in lockdown. I'm at home with my 4 boys, a husband and a dog, and it's noisy. I'm very grateful to have everybody, but it's noisy. So what kind of stimuli do we have to contend with? I've just got a couple of noises here. Let's see if they Don't jump at this one. This is the second time I've videoed this, and I watched myself flinch at the noise the last time, and that'll become apparent about my sensory systems later on. So dogs barking, water dripping, fridges humming, children playing, televisions blaring, smells wafting from the kitchen, textures from our clothes. We choose certain clothes because we're comfortable with the textures. The smells from our bed sheets, our towels. The texture of our towel is a nice rough towel because that's what I like. Some people like nice soft laundered towels. Moving from one surface to another, jostled in a busy shop, driving, cycling, playing sports, all this information that is coming in that our poor brain has to try and make sense of and contend with. So the information comes from the external and internal stimuli, and our brain has to do 3 things. It has to filter it, has to make sense of it, and it has to respond to it. So we'll start off with the filtering part of it, and it's not quite like a sieve, but the brain has to decide what information stays and which information goes. And the way it does that is because we all individually have different thresholds, so different tolerances to different sensory inputs. Some of us have got high tolerances, some of us have got low tolerances, in between, obviously. We're all different and each sense is different. So for example, my tolerance to environmental noise, as you could see when we flinching with those noises, my tolerance is low. And the slightest noise I can quite quickly overwhelm me, and I'm not able to tolerate it for long, and then I have to move away from that, or can get quite cross about it. Sets off a fight or flight response. My husband, on the other hand, has a very high threshold for noise, and it seems to just go over his head. It's not related to a hearing loss, it's just what the brain interprets. And let's take taste as another example. I have a high tolerance to strong tastes. I need to put a lot of seasoning in things. I like lots of spices and salt and garlic and chilli. And it really very rarely gets to the stage where it would overwhelm me. I mean, the hottest curry, perhaps. Whereas my husband likes very little spices in his curry or foods, and so that means that when we're ordering a takeaway, we have to have different things. But imagine a car, it needs fuel to make it start, make it go, and keep it running smoothly with good quality. It needs more than that, of course, but let's just simplify that. So imagine my car only needs a little bit to get started. So if we were comparing this to my tolerance to noise, it only needs a little bit to get it started, to trigger the starting engine and off and running. But if I put too much in, it would flood the engine and the car would splutter and stop. So those of you who remember the old cars that had a choke, you might have flooded the engine at some point, which I certainly managed to do early on in my driving career. Again, taking noise, my husband's car needs a lot more fuel for it to start and respond and run smoothly, but it doesn't get overwhelmed when it's topped up with that fuel. So I hope that makes sense to you. So we've all got different tolerance levels to each other, but we've also got different tolerance levels in each of those different senses, and at different times of the day, depending on what's happening with the other senses. So if you've got a high tolerance level, you need a lot of input before it activates this chemical response. And then this chemical response shoots the information to the correct area of the brain where it needs to be interpreted. If you have a low tolerance, that chemical response will be activated much more quickly and have a quicker response and become more overwhelmed more quickly. And obviously, as we discussed the last time, it's crucial at this stage that the brain discerns whether that information is dangerous or not. So whether it needs to respond in that fight or flight, safety, survival mode. So what happens when we're making sense of it then? So in neurotypical sensory processing, the sensory information would be relayed through various sensory circuits or tracks to the individual areas of the brain where it needs to be interpreted further, and then put together with all the different areas by the prefrontal cortex, and then it would send messages back down to the body. That sounds very simple, doesn't it? It's very, very, very complex process. Now, with sensory modulation, so I talked about being over-responsive, so that means if you've got a low tolerance to something, the brain might perceive that as a threat and it triggers off that fight or flight response that we talked about previously. If the brain's under-responsive to that sensory information, it doesn't trigger the chemical response and the brain doesn't register that sensory information. Now, it might not need to register it, or it might just not register it and you're less aware of what's going on in the environment. Sensory discrimination I'm going to leave for later, but really that's about the quality of the interpretation of the information, so the quality of the movement that we make afterwards. It's really important to understand that we also may have neurological brain injury, And where there's a brain injury in a specific area of the brain or a lack of development in that area, the information taken in may not be able to be processed in that information. So it might have been filtered, but it's then not able to be processed in the appropriate place, and therefore that will affect what happens thereafter. The response bit of it is what we see. So that's the behaviours that we see. And in the next few videos, we will be analysing much more detail those behaviours that we see. So the information has to be filtered, it has to be processed so that it can tell the body and mouth, the ears, whichever part of the body is required to make the response in the appropriate way. So in neurotypical processing, so appropriate sensory integration, the brain will send accurate information to the areas of the body that it needs to respond in that environment, in that particular circumstance. And the movement will be fluent and accurate. The other responses are much more what we would call dysfunctional. So we're either appear to be over-responsive in relation to that. So we've got that fight or flight response, or we might be under-responsive where we are not appearing to respond to what's going on in the environment, or we might be sensory seeking to try and get more of that information to help us. The fluency of the movement that we make might be poor. And also with neurological injury, the physical response will depend on the area of injury or lack of development, i.e. the motor pathway might be damaged and therefore the movement expected may not actually be possible. And it's up to us to be able to adapt the environment and provide equipment so that that response can be provided in a different way. The diagram that I have made up, I'm going to try and show you just now. It struck me that it would be really good if this was a pro forma. So what I've done is, now I haven't managed to master the screen share, and I promise I will do that for the next time. So I hope you can see if we got it at the right angle. So what I've put at the bottom is the mum saying, "Do you want breakfast?" And up here is the filter. So basically the sensory systems that really are required at this point are the auditory sense and the visual sense, and that's filtered. And the question up here is, was the input registered appropriately? So taking it round here, yes. So the information is sent to the appropriate areas of the brain, so the auditory, verbal, motor, prefrontal cortex, which communicate with one another and then send the information back down to the body to tell it what to do. So either it chooses to carry on with what the person chooses to do what they were doing because the question wasn't aimed at them and they might have figured that out earlier, or they respond to the question either with eye contact, verbally, or using a switch. The no to the input registered appropriately relates to the under-responsiveness, over-responsiveness, poor discrimination and brain injury. And the fight or flight, poor registration, poor quality of response, and not responding due to the motor or speech impairment there. And we've not set up the environment appropriately. So you could put anything at the bottom of that sheet, any sensory input, and we could work it through that way. And it might be a way to try and work out what particular thing triggers off certain behaviours, and we'll work through that as we go. I hope that makes sense. As I say, we will be exploring these areas in more detail, and I will try my best to do the screen share so that you've got some visuals and not just looking at my fidgety face. I've looked back at myself and rubbing my nose and touching my hair, but I hope you can see past that. And if you've got any questions, please ask them. I'm very happy to answer your questions with regards to these videos and try and help it make more sense. So until the next time, take care. Bye for now.